Hello world, this is Angelot, and we're going to speed run installing and using Latent Scope for the first time. We'll open the docs, copy the instructions, and paste them in our terminal. This sets up the Python virtual environment, installs the pip module, and runs the web server that's the front end to our Latent Scope module. Let's visualize some unstructured text data. We'll drop a CSV into the UI and hit submit. This copies the data and starts the process. You'll see here that our data has two columns, a question and an answer. We want to embed the answers and organize our data by those embeddings. We'll use the most popular open source embedding model, which quickly embeds our data. Next up in the process, we run umap to turn our high dimensional embeddings into 2D points. At this point, we can see that similar text gets put close together in 2D space. So we'll divide it up into clusters. This step also runs pretty quickly on the CPU. Next up, we'll want to label our clusters. If we want a quick sanity check for our clusters, we can use the default NLTK top words to generate labels for each one. At this point, we've completed the Latent Scope setup process. So we just name our scope and save it so that we can go ahead and explore it interactively. In this dataset, the concept of time is prevalent. We can find it in the clusters, and we can also do a nearest neighbor search on a query like time it takes. Here we can see this concept actually spreads across many clusters. For deeper analysis, you'll probably want to export your data into a Python-friendly format. We create Parquet files for both the annotations and the annotations combined with the original input data, as well as data for every step of the process. You can easily export a beautiful static image via the data map plot library. This often takes half a minute or so, but the results are usually worth it. This can be a great way to share an overview of your data set. Now let's take a moment to go back through the process again and make some different choices. First of all, we can use a very recently released state-of-the-art embedding model, which it's a little heavier, so it takes a little longer to run, but that's fine. We'll run umap on it again. Higher dimensional embeddings will take a little bit longer to run. The clustering will stay the same, and we can change some parameters to try to get more refined clusters. Now for the labeling, let's use OpenAI's GPT-4o mini model. We didn't have the settings configured, so we can paste in our OpenAI key. We can also resume our process where we left off because every step saves its output to intermediate files. This means we don't have to recompute anything, and if we change our mind and want to do something differently, it's very easy. So now we can run our clusters through GPT-4o mini. This is sped up, it's fast, but not this fast. And the labels that come back are quite a bit better than the top words. So we can save our new scope and explore it like we did before. Again, we can look at our clusters or do our similarity search, and we see that the data is spread out a little different in this latent space. Now let's take a look at a more substantial data set. This one has structured and unstructured information about 7,000 state legislators. We'll embed their employment history with another popular open source model. This time you can see it takes a little longer to run through the embeddings, but on my CPU this is still pretty fast. Again, we'll umap, and with more rows to umap, the longer it takes. This is sped up 2x. But the process, pretty easy. The map is also a lot more interesting to look at. Now these clusters, we may want to play with the parameters to try to get more detail in them. This part is still a little bit more art than science, but the process is so fast that you can quickly iterate and find a good clustering to go with. Here we've got 100 clusters. We'll just label them with the top words for the sake of speed, which will allow us to start taking a closer look at the data itself. So let's save this scope and explore. We'll start by just poking around. Over here on the right side we have a bunch of farmers, and then we get into directors and executives, university, school teachers, high school teachers. Go down here we see police, fire. Then we start moving into the financial sector, insurance, banks, lending. So we really do have a semantically meaningful map. Now let's look at some of the structured data. We could look at things like gender and get a sense of representation across all these different clusters. And while we can't draw conclusions just from looking at the map, this will raise questions we might want to ask of our data. Let's look at some other filters. we could look at education. When we look at law, we see the lawyer cluster light up. And if we look at high school, we see more farms and business owners and less professors and lawyers. And of course, flipping between Democrat and Republican can show us areas where they're more or less represented. For instance, farms for Republicans or unions for Democrats. There's so much more to explore, but hopefully this gets you started looking at your own data with Latent Scope.